Good morning, everybody. Hopefully you are having a good day today. Today our goal is to be able to write functions in function notation and to find functional values. In order to write something in function notation, you basically are going to replace your y value with an f of x. F of x is read as the function of x, or f of x. So we're going to write the following values in function notation. So to do that, we simply replace any y we see with an f of x. So we would say f of x equals negative 2x minus 9. We say f of x equals 4x minus 7. We say f of x equals negative 4x plus 14. And we say f of x equals 4/5 x plus 3. So as you can see, all we did was replace each y with an f of x. Next up, we have to talk about what an input, a rule, and an output look like. So our input is what we are plugging in. So in this case, we are plugging in an x. So that is our input. The rule is this stuff right here. So it is whatever the rule is. In this case, it would be a 3x plus 7. Our output is this whole thing right here. That's our output. So basically, you can think of this as a machine. So you put in your input, you run it through the rule, and then it spits out an output. So it's like a machine. So let's go ahead and try a few examples here. So here we want the output of f of 3 if our input is 3. So our input is 3. Our rule for function f of 3 is 3x plus 7. So we're going to say 3, and anytime we have an x, we're going to replace it with a 3, because that's our input, plus 7. Now, a little bit of simple math. 3 times 3 is going to be 9. 9 plus 7. So we are going to spit out 9 plus 7, which is 16. So 16 is our answer there. We're going to do the same thing on the next problem. This problem, our input is negative 3. Our rule this time is x squared minus 2x. So I'm going to simply say, anytime I have an x, I'm going to put a negative 3 in there. And then let's go ahead and do some math here. So negative 3 squared is going to be positive 9. Negative 2 times negative 3 is going to be positive 6. 9 plus 6 is going to be 15. Let's go ahead and look at a couple more examples. These ones are not too tricky at all. All you have to really do is, here we have a negative 4. So whatever our answer is, we're going to subtract 4 from that. So let's go ahead. We're going to do the same thing as we did before. So this time our input is going to be negative 2. And then we have our rule is 3x plus 7. So I'm going to say 3. And then anytime I'm going to replace an x with a negative 2. So some simple math here. Order of operations, 3 times negative 2 is going to be negative 6. Negative 6 plus 7 Negative 6 plus 7 is going to be positive 1. However, do not forget, we had the minus 4 right there. So 1 minus 4 gives us negative 3. So our final answer is negative 3. We'll do the same thing on the next one. Instead of adding or subtracting, though, this is actually telling us to multiply by 3. So on this problem, our input is going to be 5. So input is 5. Our rule is going to be x squared minus 2x. So I'm going to say x squared minus 2x, but instead of having an x there, I need to replace it with a 5 anytime I have that. So I'm going to fill those in. 5 squared is 25. Negative 2 times 5 is going to be negative 10. 25 minus 10 is going to be 15. But remember, in this case, I had to multiply it by 3. So I'm going to say 3 times my answer, which was 15, is 45. We'll keep moving here. Here we have a input of k plus 2. So our rule is 3x plus 7. So I'm going to say 3. Instead of an x, I'm going to plug in a k plus 2. And then I have plus 7. Next, I'm going to distribute that 3. So I have 3k plus 6 plus 7. 6 plus 7 is 13, so I have 3k plus 13. These are not like terms at all, so I cannot combine them, so my final answer is 3k plus 13. We'll do the same thing on the next one. We have our input on this one is going to be 2c. Our rule for this one is x squared minus 2x. But anytime I have an x, I'm going to replace it with a 2c. Now I have to do a little bit of simplification, which isn't too hard, but just showing you a small trick here. If I have 2c squared, how you actually do that? 2c squared means I have 2c times 2c. So I have 2c times 2c. To multiply those, 2 times 2 is 4. C times c is c squared. So if you forgot how to do that, that's going to be 4c squared. Negative 2 times 2c is going to be negative 4c. These are not like terms, so I cannot combine them. So I am simply all done, and that is my final answer. Our next problem, this one's a little bit tricky because I didn't give you the input. What I gave you the rule, and I also actually gave you the output. The way to know that is you have the h of x here and the h of x there. So I gave you the rule and I gave you the output. So our rule is going to be 3x plus 1. And our output is 28. A way to figure out, and I want to figure out on this problem, I want to figure out what my input has to be. That's my goal. So to do that, because both of these things are equal to h of x, I can actually set these two things equal to each other. So I'm going to go ahead and do that. I'm going to say 3x plus 1 has to be equal to 28. I'm going to go ahead and solve this out. Remember, what you do to one side, you got to do the other. So I'm going to subtract 1 on both sides. So I have 3x equals 27. I am going to divide both sides by 3. So I am left with x has to be equal to 9. So my input in this case is 9. Let's go ahead and do the next one. This should actually be a h of x. That's a little bit of a typo there, but same thing. I gave you the rule, and I gave you the output. And I want you to find the input. So, my rule is 8x minus 6, and my output is -2. Because they are both equal to h of x, I can set them equal to each other. So let's go ahead and do that. We say 8x minus 6 equals -2. What I do to one side, I have to do to the other. So I'm going to go ahead. I'm going to add 6 on both sides. So I get 8x equals 4. I'm going to divide both sides by 8. So I get x equals 1/2. So my input on this problem has to be 1/2. Next up, we got one problem left to go. This is very similar to the two problems we just did. I have our output, and I have another output. It says the graph to the right is f of x equals 3x, and I want to find when f of x equals 27. What must x be to make that happen? So I can do the same thing as I did before. I'm going to set these two things equal to each other. Now, I do not know how to undo an exponent that is a variable. So I have to just do a little bit of a guess and check method here. So I'm going to start. If I let x be 0, so let's say 3 to the 0 power, that's going to be equal to 1. Let's try 3 to the first power. That's going to be equal to 3. Let's try 3 to the second power. That's equal to 9. I still don't have that 27 yet. 3 to the third power. That actually is 27. So what value of x did I need to make that work? Well, I needed my x to be equal to 3. So the answer to this problem is x equals 3. That's it for our notes today. I will see you next time.